Understanding what happens in a glass of water. These two H2O molecules represent two molecules sitting in a glass of water. There are two different types of ions that can form. When the H2O molecules are sitting in a glass of water, hydrogen ions are transferred. In this case, a hydrogen ion is transferred to this one, creating an H3O. This will leave you with the O and the H on this side to give you OH minus. And this is positively charged. This ion is called the hydroxide ion. This ion is called the hydronium ion. The hydronium ion, written in simplified form, is H+. In this equation, Kw equals the equilibrium of water. Kw equals the hydronium concentration times the hydroxide concentration, which equals 10 to the negative 14th. 10 to the negative 14th is a number founded by a scientist to represent the minuscule number of the hydronium concentration times the hydroxide concentration. The equation to find hydronium concentration is H equals 10 to the negative pH, and the equation to find hydroxide concentration is OH equals 10 to the negative POH. You can substitute these numbers in up here into this equation. So your new equation would be 10 to the negative pH times 10 to the negative POH equals 10 to the negative 14th. Your next step in the equation is to group these two together, because two numbers with like bases that are multiplied together that have different exponents, the exponents can be represented as an addition. So 10 to the negative pH plus negative POH equals 10 to the negative 14th. Your next step would take a log base of 10 to each side to cancel out the 10. And you're left with the exponents in the top. Negative pH plus negative POH equals negative 14. Divide each side by negative 1, and you get your equation for pH and POH. pH plus POH equals 14. Now let's do an example. Let's say the pH is 9.6. We'll plug that in our new equation, which is pH plus POH equals 14. So you're going to plug 9.6 in for the pH value, plus X equals 14. You're going to subtract 9.6 from each side. You're going to get X to equal 4.4. So the pH of this, the POH, excuse me, of this equals 4.4.
When trying to find the pH value of the hydronium concentration, you are given this equation. To simplify this equation, you take a log base 10 on both sides to cancel out the 10. You're left with log of H equals negative pH. You multiply by a negative 1 and you get pH equals negative log of H. This is the same concept when trying to find POH. When trying to find the hydronium concentration and you are given that the POH is 9.3, you use the equation that was on the previous page of OH equals 10 to the negative POH. So then OH equals 10 to the negative 9.3. This equals 5.01 times 10 to the negative 10th. When you're given the hydroxide concentration and you're trying to find the POH, you use this equation. So the opposite log of 1.99 times 10 to the negative fifth. After doing the math, POH equals 4.7.